So at this point, hopefully this one is becoming a lot more familiar to you. We have done a lot of these problems at this point. So let's see what we got. So we have the graph of the function f is shown. It consists of two line segments. Let g be the function, that stuff. So first thing we should always be looking at. The graph, when I look at that graph, remember, is it a position function, a velocity function, or an acceleration function? In this case, I think you guys would agree it's the graph of f, which is the derivative of g. Okay, so this is a derivative function. Is everybody okay with that? Again, always know what you're looking at. Okay, then let's look at question A. We're supposed to find g of -1. So g of -1 is going to be equal to the definite integral from 0 to -1 of f of t dt. In regards to the setup, are we okay with that? Okay, then let's go and do that. So let's see, g of -1 is going to be the definite integral from 0 to -1. So we are talking about, first off, I think you'd agree, this is the same thing as this. So I'm using the flashcard to flip the limits of integration. And then all we're going to do, in order to evaluate this, I'm just going to go and find the area underneath the triangle that I've just colored in. Okay? Before I actually do the math, are there follow-ups on the process? And there is a question coming in. No, so the fundamental theorem of calculus says, the second fundamental theorem of calculus says if I take the derivative of g prime of x, so if I take the derivative of g of x, we get f of x. That's what the second fundamental theorem of calculus is saying. The fundamental theorem of calculus is just saying that the integral becomes, from a to b becomes f of b minus f of a. So again, I think you're thinking of the second fundamental theorem, but that has to deal with taking a derivative. That is, no. G prime of x is f of x. That is correct. But we're not being asked to take a derivative right now. I'm just doing g of -1. So no derivatives are being asked to be done at this time. So let's continue here. Let's evaluate this. So in this case, I'm going to get, this is equal to the area of that triangle. That area of that triangle is going to be, that base is, actually it's 1/2 times the base, which is 1, times the height, which is 3. And again, this is good so far. If you want to clean that up, it would be -3/2. In regards to problem, for the first part of problem 1, the position value, do you have any questions? Okay, then let's move on to the second part of A. So next you're asked to find g prime of -1. So what I'm going to do is I'm going to first find what is g prime of x. And I think you guys would agree, based on what was said in the Discord chat, g prime of x equals f of x. That's the second fundamental theorem of calculus. So I can then say, well, that f of x, now I'm going to go find g prime of -1, and that's going to be equal to f of -1. So going to my function, f of -1, right, is that height value, which is 0. So that equals 0. In regards to the derivative, do you have any questions? Okay, last part of A. I keep on repeating myself. What is wrong with me? Okay. I'm going to take g double prime of x. So I think you guys would agree g double prime of x is going to be f prime of x. In this case, and we're going to evaluate this at -1 again. So they're asking, what is the slope of the tangent line at -1? So in order to figure that out, I'm going to figure out the slope of this line, which appears to be 3/1. So it appears to be 3, unless I counted wrong. Regarding question A, do you have any follow-ups? Okay, then let's move on to part B. So for what values of x on the open interval from -2 to 2 is g of x increasing? Explain your answer. So for where is it increasing? So before we continue, there's a question coming in. I think it was negative. No, because we had a negative in front. Remember, I used second fundamental theorem to flip the limits of integration, which makes it negative. So it was -3/2. Okay, let's continue. Let's see here. So we're finding out where where the function is increasing. So first off, at this point, we should be okay with the quick way. I'm going to go through the quick way, and then I'm going to go through and remind you of a couple things here. But in general, right, the derivative is positive when f of x is positive. So in other words, it is positive for that highlighted section. So from -1 to 1, f of x is positive. Therefore, the function is increasing from -1 to 1. Okay, that's the easy, quick, I want to just kind of bust through this really quickly type reasoning. Answer. Of course, we could go through the reasoning in just a second. If you're not comfortable with that, though, quick reminder. I can make a sign chart. But do remember, sign charts do not count for AP. Critical numbers occur where the derivative equals 0 is undefined. So in this case, they did not tell us it was undefined. So I have critical numbers when f of x equals 0, which is at -1 and 1. To the left of -1, the function lies f of x is negative. To the right of -1, it is positive. To the right of 1, it is negative. So from on the interval from -1 to 1, f of x is positive, therefore g prime of x is increasing. So my reasoning, and I'm pretty much going to be there, I'm going to say so. A couple things I want to point out here. One, I want you to notice how I pointed. I said, look, the question was about g. It's asking where is g increasing, right? So I said, well, hey, look, g prime of x is equal to f of x. Now I'm talking about f of x. Look, f of x is positive from -1 to 1. What does that tell me? That tells me g is increasing. But the pointing, they asked about g, so I said, hey, look, I'm analyzing g by looking at f. In regards to question B, do you have any follow-ups? Also, a quick note, it would absolutely be wrong to say, if I started out my first part of my statement saying g prime of x equals f of x, then I said on the interval from -1 to 1, f prime of x is increasing. That would be wrong because, again, if I'm using the word increasing, I'm saying I'm taking the derivative, which means I'm looking at the second derivative. So be very careful. So the next question, the question came in, aren't you technically looking at g prime, not g, by putting in terms of f? So remember, when we talk about a function increasing or decreasing, we're talking about its derivative. So I'm saying, I'm looking at the I'm going to go and analyze if this function is increasing or decreasing. How am I going to do that? I'm going to take the derivative of g. Okay, I've taken the derivative of g, it equals f of x. Now I'm going to analyze f of x. So I'm still talking about g. Again, I'm talking about g by saying I'm looking at f. That is fine. I hope that answered that question because I kind of lost it in the middle. Okay, are there any other questions in regards to B? Okay, let's look at C. Whoops, that is not my highlight tool. Okay. So, for what values of x on the open interval from -2 to 2 is the graph of g concave up? Concave down. Explain your reasoning. Okay, so we're talking about where is it concave down. So the first thing, just like I did before, I'm going to do my pointing. So when we're talking about concavity, we're talking about the second derivative. So I'm going to say g double prime of x equals f prime of x. Okay, I've pointed, now I'm looking at f prime of x. Now, since when we talk about f prime of x, right, we're talking about concavity. And the only way we can talk about concavity in this thing is we're talking about the derivative of this function right here, right? Now we're talking about the derivative of this function. We're talking about the slopes of tangent lines. So from my perspective, right, I want to know where are the slopes of the tangent lines. Let's see, let me just make sure, concave down. So in other words, I want to know where are the slopes of the tangent lines to the graph that I just put that arrow to, where are they negative? And I think you guys would agree from here to here, all the slopes of the tangent lines to the graph of f would be negative. Okay? So what I'm going to say is okay? Any follow-ups on that? So the big thing I want you to notice here is now I'm using the word increasing, or I'm using the word decreasing, because I'm saying, hey, I'm looking at the derivative of f. I can't say positive, negative, because they didn't give me the graph of g double or g prime. I can only talk about, oh, did we just crash? Can you guys hear me? So because on mine I'm crashed. So type 1 in the chat if you can hear me. Oh, I got some ones. I don't know what's going on because I literally am crashed on mine. I don't see. Let me. Oh, okay. Hopefully you guys are good because I don't know what happened, but I appear to be good. That's good because I didn't want to have to re-record. Okay. Don't know what happened there, but thumbs up so far. Okay. So let's go back here. Let me see what we have. Some questions were, okay, I'm confused about the part of your explanation that says f double prime of x equals f of x. That doesn't say that. That's my apologies. That's messy. That is g double prime of x equals f prime of x. So that's just messy handwriting. I apologize about that. Second, let's see. It says, do you need to repeat g prime of x equals f prime of x? The answer is no. You do not. As long as it's somewhere in your thing, you don't need to. So I could have, if I wanted to keep this shorter, and I had started out with this, I could have said this, and that would have been fine. Okay, you don't need to repeat it. You've already said it once. You've talked about what you're pointing to. Let's see. I don't think there's any other questions I missed during that, but just make sure in case I missed something while I was worried about it crashing. Is there anything I missed in regards to letter C? No. So the question was, should you also mention that the slope is -3? Don't need to. All I have to indicate was that it was decreasing. I don't have to. All I had to indicate that it was decreasing on the interval. That the specific number does not matter. You are more than welcome to use a specific number as you say, hey. But if you're going to use a specific number, make sure that you're indicating it's negative. Therefore this thing's decreasing. Okay, but the number itself does not matter. Okay, if there are no other questions on C, I'm going to move on to D. Obviously, there were no axes provided. So let's do that. Okay, so what do we got here? We're going from -2 to 2. And I'm going to plot a few points here. So first off, and I'm going to need your help with it, please remind me, was g of -1, was it equal to -3/2? Is that what I had? I think it is, but I'm not positive. Just please double check. Perfect. Okay. Perfect. I just want to double check. Okay. So we have that. Also, so let's plot a few points here. Some things that we know. I think you guys would agree that g of 0 is 0. Let's get some other points here. Let's see if there's any other points that would be nice to have. Also, I think you would agree that g of 2 is also 0. I'm just giving myself a few points. I don't know if I need this many, but it might be nice. And then finally, one more point that I'm going to put in there. G of -2 is also 0. Let's see if that makes sense to me. Those two cancel each other out. That's correct. We already know that. That looks good to me. I think that looks good. Are there any questions on those values that I kind of got there? I just want a few points to start off on. How did I know g of 2 and g of -2? The answer is, so let's say, so and again, I kind of did this in my head, but that's fine. So if I want to figure out, I think g of 2, I'd take that integral from here to here. And notice these two triangles cancel each other out. Okay, so those two triangles cancel each other out. So that equals 0. Right, if g of 0 is 0, and yeah. Sorry, I've got a mower in the back and it's really distracting. Okay, let's see here. And that's what I did for g of -2. The other question is, what about g of 1? G of 1 is important, but I don't, I haven't dealt with it yet. But you're right, g of 1 and actually g of -1 are going to be important too. Okay, and I think we already found g, yeah, we did find g of -1. So let's also find one more point. As was pointed out, I'm going to find g of 1, which I think you guys would agree, that's the integral from 0 to 1 of f of t dt, which is just the area of that triangle, which is +3/2. Okay, let's go and plot some points. So what do we have? We have zeros at g of 0, g of 2, and g of -2. We also have a g of -1. G of -1, it is -3/2. So let's call that this. And that g of 1, it is +3/2. Let's call that this. Okay, now I know this, you probably already kind of know what this looks like, but let's just say for a second that you didn't know what this looks like. Well, let's look at the derivative of g prime. What do we normally do? We make a sign chart. And we already did this earlier, but I'm going to make a quick sign chart again. So -1 and 1 were critical numbers, and we said that this went like this. So it's decreasing from -2 to -1, and then it's going to be increasing all the way up to 1, and then it's going to be decreasing from 1. Also, looking at concavity, so g double prime of x, we said the inflection point occurred at 0, and we said that it was increasing, it was concave up from -2 to 0, and then it was concave down. That's a down, not a plus. Concave down, right? So concave up, concave down after 0. So now let's go through the graph. We've got our points. So we should be decreasing all the way to -1, and it should be concave up. Okay? It should be increasing from I'm going to go to 0 here, -1 to 0, and still remaining concave up. Okay? From 0 to 1, it's still increasing, but now it is concave down. And then from 1 to 2, it's going to be decreasing and continuing concave down. Kind of messed that up a little bit, but you guys get the point. And that's our graph. Any questions on the graph? No. So the question is, does College Board care about how you drew the slopes? No. No, they don't. The only thing you have to be careful is that you want to make sure that at those critical numbers, the derivative equals 0, right? So at this critical number, it should go flat. At this critical number, it should go flat, which I didn't quite make, and that there should be an inflection point at 0, which, I think that's good enough. So you just kind of want to make sure those things are indicated. Critical points, inflection points, you want to emphasize those things. Okay? Any other questions regarding number 14? Okay, let's move on to the next one. So the next one was... What was the next one? The next one is 21. So let's move on to number 21. I did it all, right? Did I? Yeah. Let's move on to 21. Just a couple notes before I begin. I believe in maybe this has been changed or whatever, but it sounds like College Board is going to allow you a calculator throughout this the testing. So do make sure that you're very comfortable with your calculator. I know this is a non-calculator one, but I just want to remind you that I think that was the rules, that you are going to be allowed a calculator throughout this time on the, 3 questions they're going to be giving. Okay, let's see what we got here. Give me 1 second. I've got thousands of people emailing me here. Okay. So the volume of a spherical hot air balloon expands as the air inside the balloon is heated. The radius of the balloon in feet is modeled by a twice differentiable function. That is important. So I'm going to highlight that as a twice differentiable function, r, of time t, where t is measured in minutes from 0 to 12. The graph of r is concave down. That is probably really important. The table above gives selected values of the rate of change. So actually, I don't need to highlight that. Of r prime. Of the radius of the balloon over time 0 to 12. The radius of the balloon is 30 feet at time 5. So they gave us a point. They gave us the point 5:30. Okay? So, and then they gave us a volume volume thing. So again, as always, the very first thing I should do, and I think they've made it pretty obvious on this one, but I should look at the table and I should ask myself, are we looking at position, a velocity, acceleration? I think you guys would agree. It's clearly a velocity function, is the rate of change of r. So r, when we look at r, is going to be the radius. R prime is going to be the rate of change of the radius. And then I don't know if they're going to ask about the second derivative, because that would be kind of weird, but I guess you could. Okay? Before we jump into part A of this, do you have any questions so far in terms of clarifying thoughts? Okay, let's jump in. So, estimate the radius of the balloon when t equals 5.4 using the tangent line approximation. T equals 5. Is your estimate greater than or less than the true value? Give a reason for your answer. Okay. Let's see what we can do. So the first thing we're going to do is going to write the equation of the tangent line. And we're going to write the equation of the tangent line to the point 5:30, right? Because they want it to be at time t equals 5. So we're going to write the equation of the tangent line at 5:30. So in order to write the equation of the line, we always need two things. One, we need a point. Check. We got a point. Two, we need the slope of a line. And I think you guys agree in order to do that, we are going to need to know what is r prime of 5. Okay? So let's see what we got. R prime of 5 is given to be 2.0. And we have the point 5:30. So the equation of our line is going to be y minus 30 equals 2 times x minus 5. And I'm going to, they didn't ask you to do it, I think. Let me double check. Nope. I'm going to just solve this for y. For ease of use. But I don't have to. Okay. There's the equation of my tangent line. Next, I'm supposed to evaluate this at 5.4. So I get y equals 2 times 5.4 minus 5 plus 30. Remember, you're done here. If you want to simplify it, you can. So we get, what is that, 0.4? So 0.8 looks like, is it 30.8 maybe? If we want to simplify, I'm kind of doing it in my head, so take that for what it is, but we don't need to. So I'm going to leave it like this because that way I can be right. So first off, before I continue and answer the second question, are we okay with finding the value of the radius at 5.4? Okay, next. The question is your estimate bigger or smaller? So let's think about this for just a second. I'm going to make a quick graph of this function. A very poorly done graph as always. We were told that the graph was concave down. So here's my graph. It's concave down. I just drew a tangent line to the graph, right? I created a tangent line. So here is my tangent line. I just then evaluated the tangent line at a point. So for example, I evaluated here. I think you guys would agree, based on this graph, that my point is an overestimate, right? It's too large. So I'll take care of it in writing in just a second, but my answer is too large. Why? Because the function is concave down at that point. Okay? Questions that you have before I put that into writing. Okay, let's see what we can do. Let's see if I can put this into English, which I'm going to struggle at. Okay, sorry. Took me a little bit here. So, things that I want to emphasize here. One, do you have to rename the point, the value? Probably not. The big thing that they're going to be looking for is one, was an overestimate or an underestimate? And two, how you knew that. And I knew that because, so they're going to want to specifically, you're going to have to specifically mention that you were looking at concavity. If you say it's an overestimate and you say concave down, you probably got full credit on that. So there's an image here, which, let's see if I can see that. That is really rough to read. Larger by the greater the time. I'm going to go with no. So the question was, could we use, is this correct too? I'm going to go with no. I think you really have to use the word, you have to talk about the concavity. They're basically looking for the word concave down. My guess. So they're probably 2 points, 1 point for overestimate, 2nd point for concave down, and everything else is just what it is. Okay? In regards to that question, do you have any follow-ups on whatever question that was? A. Okay, let's move on. Or try. Okay, find the rate of change of the volume of the... Wait, no, I didn't do that. Okay, find the rate of change of the volume of the balloon with respect to time t. To time when t equals 5. Indicate units of measure. Okay, so let's see what we got here. We're asked to find, that one confused me. I was like, didn't they give us that? No, but they're asking about the volume, not the radius. So, okay, we're asked to find the rate of change of the volume. So they gave us a formula, and the formula is volume equals 4/3 pi r cubed. And do note that we know there's some things that we know here. So let's keep on, let's take our derivative here. So this is with respect to time. So I'm going to get dv dt equals 4/3 pi times the derivative of r cubed, which is 3r squared, dr dt. dr dt. So from here, we can simplify that, and we get 4 pi r squared dr dt. In regards to taking the derivative implicitly, do you have any questions? Okay, from here, we're going to start plugging in some things that we know. So what do we need to know? We were doing this at time, the question was at time 5, right? So we want to know when at time t equals 5. So at time t equals 5, we already know that r, it was given to be 30. We need to know that. We also know that dr dt at time 5 equals 2. So I can plug those values in here. So I'm going to say dv dt equals 4 pi times r squared, which is 30 squared, times dr dt, which is positive 2. And then finally, we have to talk about our units of measure. So our radius is a linear unit, and what was it measured in? It was measured in feet. So this is going to be feet per minute. Nope, I'm sorry, we're talking about a volume. I apologize. We're talking about a volume, so this is feet cubed per minute. Okay? In regards to letter B, do you have any follow-ups? So this question coming in. Let's see. So units, because they ask for units, so the question is units a point as usual. And the answer is, if they ask to include units, then they are giving a point. Now, they may ask to do it over multiple ones. Let's see if they do. They don't. So yes, units are a point. You would get, so in this case, my guess is the grading would go as follow. And again, this is my guess. So probably 1 point for your derivative, 1 point for your number, and 1 point for your units. That would be my guess that this would be a 3-point question. Any other follow-ups on letter B before we get to, oh, that looks bad. Before we get to C. I don't even want to do C. It looks terrible. Okay, let's move on to letter C. So, use a right Riemann sub with the 5 subintervals indicated by the data in the table to approximate this. Okay? Using correct units, explain the meaning of that in terms of the radius of the circle. Okay. Whew. I would have liked it not to be 5 subunits, but whatever. Let's do it. Okay. And we are using, it said right Riemann, yeah. Okay. So let's see what we can do with that. So we are finding the, so remember in this case what we're doing is we're going to be using right hand side rectangles to approximate our area underneath the curve. So in order to find the area of a rectangle, it's going to be base times height. So my first, if you look at this, I'm going to be doing the following. So my first base has a width of 2. Or actually, let me do this. Let me backtrack just 1 second. So we're going to say the integral of this is approximately equal to, and so let's go through and indicate here. So we're going to say our first rectangle has a base of 2. Actually, I'm going to even backtrack just a little bit more. You don't have to do this. I'm just doing this for you just to make sure we're good. So the base is 2 minus 0, and then we're going to be evaluating it at r prime of 2. Then to that, we're going to take the next base, which is 5 minus 2, and we're going to be evaluating that. I keep on writing F's. Going to be evaluating that at r prime of 5. To that, we're going to add, 7 to 5. And we're going to take r prime of 7 plus 11 to 7. And we'll be doing r prime of 11. And then finally, I'm going to be doing, I lost it. There it is. 12 to 11. And it's going to be r prime of 12. Okay? Before I do that, before I go and simplify this, concept-wise, are we okay? Any questions? Okay, then let's see what we got. So this is equal to 2 times r prime of 2 was 4 plus 3 times, I'll get to your question in just a second, Naz. So 3 times, what was it I did? R prime of 5, which was 2 plus, sorry, I need to keep track of these. This is kind of a mess. 2 times r prime of 7, which is 1.2 plus 4 times r prime. Did I say 1? That's not right. What was it supposed to be? 11. That's weird. So r prime of 11, which is 0.6. And then finally it is 1 times r prime of 12, which is 0.5. Okay? And then I think, did they ask for units or anything? They asked for, actually, they did ask for units. So this is the length of the radius. So our radius was measured in feet. So this is feet. Okay? So the question is there a reason you did not use r prime of 0? And the reason I did not use r prime of 0 is they're asking for right-hand side rectangles, right? So if you imagine our first, if we were to draw this graph, and again, completely non-accurate, here's my graph, and I were to break it up into 3 rectangles, right? The height of each of these rectangles would be based on the right-hand side of the graph. So if you notice, I'd be using this, this, and this to determine my heights. Is that okay? Perfect. Okay. Now let's see. Was there another part to this? Am I missing anything? Are we on letter? We're on letter C. So we found the value. We used correct units, and then we had to explain the meaning. Okay. So the meaning, and we got a couple pieces to do here. So I'm going to say, so big things that you want to point out here. One, it represents the change in the length of the radius. That's important, right? We're talking about the change in the size, but also it's important from when to when. Okay? So both these pieces are really important. Not just that it's a change in the length, but over this specific time period. So I'm talking about, when I'm talking about this, I'm discussing the limits of integration along with the radius. In regards to letter C, I think, do you have any questions? Okay, then let's move on to the last one. And I'm going to erase this. Okay. Excuse me. So is your approximation in part C greater than or less than the actual value? Give a reasoning for your answer. So one more time. Is your approximation greater than or less than? Okay, so I think you guys would agree what they're really asking for is we're addressing concavity again, but we have to be a little bit careful. They told us R is concave down. So, hold on one second. So, is your approximation greater than or less than? So we got our value, and now we want to know, is this approximation? I'm trying to figure out what are we doing here? Give me 1 second. Okay, so let's imagine this for a second. So I think I've got this now. I've kind of saw what they're doing. I was trying to figure out why the difference between this and part. Yeah, that's exactly what we're doing. So let's just let's just kind of look at a graph really quickly. Again, this is going to be a non-accurate graph, but let's see what we got here for help illustrating. And I'm going to be a slightly more accurate than usual, not much. So at time 0, this thing is 5.7, which I'll just say is here. At time 2, this thing is 4. At time 5, this thing is 2. At time 7, this is 1.2. Time 11, I probably don't need to go this far out. Okay. Then, and time 12 is 0.5. But for illustration purpose, now, what do we also know? We also know that those are our values for R prime, right? So let's just kind of make a quick graph. What'd I do? How did I do that? So let's make a quick graph on this. would you guys agree, I'm just kind of making this up as I go, if we used right-hand side rectangles in order to figure this out? So our graph would look, our rectangles would look something, let me do this in a different color. Our rectangles might look something like this. I think you guys would agree, except for the crappiness of the rectangles. Would you agree that all those rectangles, when we add them up together, are going to be less than the area underneath the curve? So my answer is, in this case, the value in part C is an underestimate, and the reason being is the function is decreasing on the interval we could say monotonically decreasing on the interval from 0 to 12. Okay? Before I put that down and try to spell the word monotonically, I don't think you have to use the word monotonically. You just want to indicate that it's decreasing on the interval from 0 to 12. So if the function had been increasing on the interval from 0 to 12, all our values would have been an underestimate, but in this case, it was decreasing. Okay? Again, I don't think you need to say monotonically, but if you really want to show off and be awesome, you can. Okay, so let's see if I can write what I just said in a sentence. Okay, so things that they are specifically looking for is that you are mentioning that you recognize that it was decreasing on the interval. My guess is if you have that line right there, you're good to go. In regards to letter D, are there any follow-ups? So there's a question coming in. So the question is, are there any questions with more than 4 parts? I'm going to say that I can't think I've ever seen one, but that doesn't mean there wouldn't be one. I mean, you have to remember they kind of have to keep it to one page. So I have never seen one, but there's no rule. I've seen ones with 2. I think I've seen ones with 2. Okay, so before my live stream crashes, which I'm very worried about because this was a long one, I'd like to throw this one up on YouTube. Before I do, any follow-up questions, what I am going to do is I will be available in Discord in the general voice channel if you have any other questions that you want answered either about this or if you want to have questions about multiple choice. I don't mind if you want just some one-on-one a little bit, that's fine. The only thing I do want to remind you, just again, one more reminder, I would strongly suggest going to the AP Central site in order to check out some of the resources they have. They have videos. They're probably professionally done by, professional people who are good at this and not me. So, and I think they even have some practice things that you might be able to play around with. You might want to do that, get a better idea of what is going to be expected on the actual AP. Okay, so if there are no other questions for me, I'm going to end the live stream. But again, I will be available in the voice channels or in the in this channel right now for a bit. So please feel free to ask questions, any questions that you want to ask. If you want to know anything about World of Warcraft, I can answer those questions too. Okay, well, again, as always, I thank you very much for your time. I will see you tomorrow where we will go over multiple choice information.